All right, so my topic here is challenges when scaling the code base. What I'm going to tell you the story, how the code really evolved from 10 engineers, back engineers to 300, and what's the problems that we faced when the engineering was growing. Basically how we ended up with Monolith. I'm Will, I have 20 years of experience, joined Roblox in 2018. I'm leading a team responsible for microservices and developer experience and productivity. So Roblox opened the shop in 2006, roughly 2007, on Microsoft technology, which means C#, IIS servers, and pretty much anything around Microsoft, Windows, and all of that. So if we start this story as we had 5 to 10 engineers working on a backend, how this story really starts. We decide to create something called Roblox website. And what usually happens is you end up with Roblox website. It has endpoint to show the homepage. You have to authenticate, a few other things as well. And then kind of like your Roblox website in this world has few libraries, user library, data access library, just a simple things. That's how usually every project starts. Then you kind of evolve that, and you have a lot of public endpoints. Then also you have a lot of libraries here. And now, if you're very lucky, you actually get the chance to deploy this thing to 100 different servers, and everything works great. Until it doesn't. So until you realize that some endpoints are actually getting 100,000 requests per second, and some are only getting 10 requests per second. And so what we decided at that point is, well, the easiest thing we can do, we literally split the whole website into a website and something else, and that something else we can deploy to 300 servers, and we can deploy to 100 servers the original website. And this is, remember, this is like Windows, IIS servers, like there's the usual stuff. And on the parallel side, different view on the same problem is what's happening now with the code dependency. There's a website, libraries, and all that. What's happening with that? So this is just a plastic example of how this could look like. You have a user library, get user by ID, billing library using that, website, some other service, and it's pretty much very simple. Now you have this many people. The team is handling this very easy. Next thing, what happens? Well, you decide, like, let's actually have user languages, and you add a little language library. Pretty much that's your dependency tree right now. You have a little bit more people. Kind of like everything is still manageable. Everyone works on everything. There's no problem if anyone touches anyone else's code. And then you say, like, all right, so let's add this something is special user. This required some kind of like game assets library. And then you say, let's add globalization info, globalization library. And then you say, well, actually, let's add like common data access library. You add some more dependencies. And, well, basically, you end up with a little bit more people that still kind of go all around. They can understand the whole thing. And everything still runs without any problems. Now, like a few years after that, you actually, if you follow this pattern, you end up with this whole big mess of dependencies, and you end up with a little bit more people that now need to manage all this stuff. And, well, it doesn't sound like a very well-organized company anymore. It's like who is working on what and all of that. So what this really means, it's impossible to form teams to work in a normal style, like, team working on something. So everyone still needs to touch something, but that's not how it works. And of course, there's a third most important fact, is no single human can understand the whole system anymore. So then you start, well, we need to break up the monolith. So let's break it up. And this happened to Roblox, I would say now, maybe like 4, 5, 6 years ago that this process started. And how it actually happened. So we have this website, libraries, a lot of libraries in the website, and we decided to extract some things into something called infrastructure service. And the idea of that was this service is going to be something we deploy as well, but it's going to have only few libraries that are just necessary, and it's only going to do only certain thing. And that sounds very great. But this is how you allocate people. So we actually had only this number of people versus this number of people working on supporting the growth of these companies. Growing, number of features, requests, and businesses driving this. So everything grows. And unfortunately, you don't have enough resources to just throw in, like, let's say, let's do a tech cleanup and break up the monolith. So is this good? I would say, yeah, we're very lucky. Actually, the business is growing. Like as a company, we're successful. But unfortunately, we don't have enough time and capacity to break the monolith. What about the coding productivity? Like when you ask engineer, like how productive you are, how fast you can do something? Well, if you start with like small number of engineers, then you're super productive. Everything goes all around. People are just like amazing adding new features. Then you double that, and your productivity is like 95%, still very good. You double that, goes down to 80%, still manageable, the whole thing. You double that, and now it's not going down to 70%, it just drops. And you start to add more people to this, and now basically you are almost grinding this machine to a stop, which is a very big problem. So let me give you the real example. When I joined this company, how I felt this problem. So I was given a small task to extract a small thing as this infrastructure service. And this thing had only 3 operations and was dealing with one simple SQL table. So it took me almost 3 months to do it like in a high quality, production ready, scalable way. This is how like, you know, and then I kind of started questioning like, well, this is like a, you know, questioning my skills, you know, something's maybe wrong. So we needed to fix this if we wanted to support our growth. And first of all, how you decide like to do anything in the future. Well, you set up the most ultimate ideal goal you can have, and you try to hit it. If you hit half of that, it's still good. So if we had the magic wand to fix all the problems, what really we would like? We would like something like this. So you have like a C# service that has only a few libraries. You can maybe introduce Go language because of some requirements or whatever, necessities. You know, machine learning guys like Python, so let's use Python, have a little service that does like something in Python, small number of libraries, of course. C#, another service, completely different set of libraries, different requirements, different business needs. And of course, you introduce teams, and luckily you get like this number of people working on their own services. Everything is great. And in the perfect world, they also do have their own build release pipelines. They release to their own servers. They scale their system however they want, and everything is amazing. But how you get from what we had, or I would say the typical company experiencing growth has, into this amazing world? And how we solved or how we approach to solving this problem. So the first solution we kind of implement is, well, let's prevent engineers from adding more dependencies to a monolith somehow. What we decided to basically do is we introduced a new set of technologies that just it's not compatible with the old stuff. So that way, just simply, if you use Go language and we are in C#, like, well, you cannot just add the dependency to the monolith anymore. Same goes for .NET Core. .NET Core was out, enabling us to run on Linux. Didn't support actually what we had in the existing C# framework, so it didn't work. And what we did is actually these new things are actually at least not going to grow the monolith, which is very interesting. So how we actually enable people to actually use something else aside from C#? Very simple. Well, actually, very simple sounds now, but it's not very simple. We needed to change the whole deployment mechanisms. Like on this scale, like this needs to change. So we put in place something called Nomad HashiCorp. We're going to have a little chat about this a little bit later. And then we also containerized everything using Docker, which is great. Docker containers run on Linux. You can wrap anything you want, Python, C#, Go, whatever you want, and everything works. Solution number 2. So we gave engineers the power to have their own build release pipeline. So how? Basically, they keep the configuration of their pipeline within the repository, and they use that file however they like. And now they can set up their own policy. Do they want to release every single day, every single hour? Like, it's up to them. The next thing is actually coming down to the code. So how you code, like you have a new service and you want to make sure that your service is like production ready, high quality service supporting this large scale. So what you need to have? You need to have proper logging on that service. You need to have proper metrics. That metrics means like you need to count requests per second, memory, CPU. You need to have alerts if that service goes down. You need to have proper communication with databases and services, like clients, right? That clients need to be not just a simple clients. These clients need to have protections, circuit breakers, retry policies, timeouts, fallback mechanisms if the other service is not there, something's happening. You don't want to have cascading failures, so you need to have some protections. You need to have health checks, which means uptime checks and readiness checks. If your service is like up, it doesn't mean it's ready to serve the traffic. And then you really do your own coding. This is actually our third solution. So we designed a tool to generate all of that, except, of course, that little green thing, your own code. And our idea of that was it should take you less than an hour to do all that. How we eliminated this coding, like how it actually works. So we created a tool called Swarp, and this is just an example like how easy it is to do something. So let's say I want to create a Roblox economy. I just do Swarp new product, Roblox economy. Then I want to have a gRPC service called Google Payments, and I just create this thing with one single line of code. I create another service, and it kind of bootstraps everything for me with all these alerts and all this stuff I mentioned, and you just type your code, and then you say, I want to build it, and you say, I want to deploy it with this number of instances, and then we're talking about Docker images here, what is the tag, and I just deploy that, I deploy the other thing, and that's pretty much that. We auto-generate the most common metrics, alerts, we use Grafana dashboards. We have the boilerplate code supporting REST services, gRPC services, processors. We auto-generated clients, and also these teams have their own build release cycle I mentioned. And this is a very interesting thing. This is how it looks for real. This is like me just executing this, and this is a little GIF. And this is kind of the notion of our team when we take approach is like if you can put this as just a simple GIF, that means the whole process is very simple. So as long as you can keep putting it in a GIF, it's a simple process. Kind of that's pretty much how this whole thing runs. And literally I'm creating these services here, and I'm going to deploy them and all that, but I'm going to skip the slide. It's actually like 60 seconds long. But anyway, next thing is solution number 4 is each microservice should have only a small footprint of code, only a few thousand lines of code, which is great. If you have that small service, it does only specific business requirement. You are in a good shape, your team can maintain that. Not just maintain, they understand 100% of the code, which is great. If you go back to the dependency 3, there is no way people, like single person can understand the whole thing. In this case, every member on the team, you hire a junior engineer, you hire a senior, it doesn't really matter. 2,000 lines of code, that's manageable. People can understand that. So, and what that gives you, the power to rewrite a service in a week. And now you're in the good shape, IT industry changing all the time, maybe there is a new good technology on the block, and you basically are able to rewrite service very quickly. Solution number 5 is we decided to force designing interfaces first. This is a very important thing for us and very big difference to how we used to do things before. Which means, let's say you have a team A that wants to use some other service that's not owned by this team. They need to start with a contract, and typical contract, familiar with everyone, hopefully is gRPC protofiles or maybe Swagger. That thing uses a generator and gives you the client. And not just gives you the client, it gives you the client that's reliable on the scale, has circuit breakers, protections, and all that stuff needed. Let's say team A needs to use a database. Well, you don't start with a database, you start with a data store contract, and then you transform that contract through generator into a client that's talked to a data store. And so that's kind of the whole idea. It's like always the same. You deal with the contracts and all of that. When you introduce contracts, actually the contract becomes the only thing that teams can share. And that's great. They don't share the code. They share just a simple file, which is a contract that you store in a common place or wherever you decide to store it. We decided to use the common place. Then, how we think about improving coding productivity even more. This is great. This is like what kind of we are rolling right now, but how we are thinking about this in the future. So the most ideal thing, if you kind of dilute this as an algorithm, like how you can like crunch this out, would be something like, well, every single thing is a business need. Going back to like the endpoints, you have an endpoint 100,000 requests per second, you have another endpoint 10 requests per second. Each of these endpoints serves a single business purpose. And so in an ideal way, you have like, let's say a few people working on purchasing item and only purchasing item feature. And then they control their own build release pipeline, cycles, scaling of that problem and monitoring that business functionality. The same goes for like, let's say searching games, same thing. How to get game details. Same thing, kind of the story is like now everyone controls the little domain of the business, not the whole thing. And this concept is very familiar, very popular right now. It's a serverless development, function as a service, however you want to call that. And we have a very common case to use that. So this is something that we are kind of like planning. Now going back to the real stuff, it's like, so what about this big monolith? We still have this monolith, like this, I didn't mention anything how you get rid of it. Well, I really can say this is one of the hardest problems. And like there is no solution. There is no like, hey, this is how you do it, and like now everyone knows like this is how you should do it, and you follow the process and everything is done. That's not as simple as that. But there's some ideas around this. How we can do it is, well, we can say, well, okay, keep legacy stuff running, and just duplicate the code that's needed. So basically extract kind of like a sub-branches from this big dependency tree, and you should be good. The other way to look at this kind of problem is, well, identify what is a core library, like access to data, logging, whatever, and then what is a library that has a business functionality that we implemented before. And then extract that business functionality as a service, and this basically just replace the library with clients, and kind of you are in a better shape. But the whole catch is this, like this company is growing fast, and again, features versus this is a tech debt. There is really no like, you know, like hard commitment to actually do that, and really there is no like incentive to do it as soon as possible and cover everything. So we kind of do it slowly when really necessary, case by case, problem analysis and all of that. And we're kind of hoping maybe we're going to hit the magic pattern that's going to work for us. What we have right now, we have 90% of the existing code still is part of the monolith. But this new world that we created kind of enabled engineers to be way more productive, and this really means they want to work work away from the monolith. They want to work on this new thing, which is great. They want to put new features in a new world. And the fact, the monolith is never going to go away. And this is very interesting. Like I compare this to ASPX pages. There's a typo here, which are very legacy technology from Microsoft. We still have those pages in our code somewhere successfully serving millions and millions of requests. We still have them. Are we ever going to go away, remove them? Maybe, but there's no really like a need to remove them right now. And that kind of concludes the whole discussion about like the monolith and how we went to solve the coding problems. Any questions?
You get a toy. Okay. I got one.
So I've been through this journey a couple times now. So, you know, if you have these tools in place, you know, realistically, you say you've got 90% left of the monolith to kind of go. What is the like limiting reagent right now? Like, what stops? You know, is it just we want to work on new features, and so the, you know, 90% becomes the same size but part of a larger pie of new features, or yeah, I'm curious how does it more? Sorry, if you could speak more to like how you think it'll progress, and like, is there any kind of timeline, like a year, 2 years?
Yes. So we kind of project that, and we have like internal slides that kind of like they do these projections. But so what we hope is, of course, since people are moving and creating new features in the new world, this ratio is going to change. And we kind of think that by the end of this year, maybe this number is going to be 50-50. And then, of course, like this requires a lot of effort, a lot of like, you know, push to happen. And then after that, we kind of believe that like maybe in like 3 years, 4 years, we'll be kind of like in a just a legacy kind of like, you know, support mode on the existing monolith, which probably will be maybe like 10-20% of the things.
That was really a great talk. What I wanted to ask is, how do you make sure that these different verticals, they don't get siloed and start working? Basically, how do you make sure that there is efficient collaboration between those different cross-functional verticals?
That's an amazing question, and one of the biggest challenges we have as a team, considering that our team is responsible to handle that. So on one side, we are dealing with this legacy stuff. So let's say you join a Roblox, and if you want to like learn about these two things, you need to learn how the legacy systems works, and you need to get familiar with the new stuff. The good stuff about this is we are preparing like very good onboarding sessions. Like we kind of have internal school, how like to go through all of this and kind of like understand the concepts and what is that all about, what's the difference, and you get to feel both worlds so you can compare. But essentially what we've seen is in 6 to 8 weeks of proper onboarding, like anyone is able to kind of effectively work on both parts, with, of course, the hope and the goal of working only on the new stuff. I'm not sure if that answers the question.
No, perfect. Thank you.
Okay. All right. So, one more.
All right.
Hey, thanks for the talk. So I was just wondering how you measure productivity. You said you were going from 100% to 90 to 80 to 20.
Nice.
What's your true North Star there?
Yeah, so this is interesting one. How we measure that? We just ask engineers. Like, literally, we asked engineers like, "Hey, how do you feel doing this?" And we try to collect kind of like objective measures, like CSAT scores, NPS scores, and stuff like that. And also the other thing we do is we collect like the details. So it's kind of like, I would say we approach this problem from a typical user experience kind of like angle, where like, you know, we're kind of like working with regular users of Roblox. Hey, how we like this? You know, we'd like to improve that, and so on.
Just one more follow-up on that. I think the other one that we're looking at is time to first change set. So a brand new employee who has no concept of our backend, I think it's pretty fair across the board, and it should be getting better over time. So if it takes 3 days and then 2 days, et cetera. Other ones are we have a really cool summer program for interns, and a lot of them have never worked professionally before. It's their sophomore year, something like that, and them being able to deliver in production, you know, within the first month is a interesting metric. So just tracking that data over time.
All right. Oh, one more. Oh.
So I think in a normal way, if it's not necessary, people tend to delay, you know, how move from the monolith to microservices. Have you thought about like maybe you have like some hacker week or fixed week once in a while? That actually, in my past experience, it really helps.
That's exactly what we're planning. So soon we'll have this internal school basically for this, where you kind of like go to see the new thing, and we are of course inviting the old engineers who never seen this new world, like, hey, how can you use this? So it's basically like a very amazing onboarding thing that we are planning for the engineers who want to kind of explore the new stuff as well.
Thank you. I noticed there's a diagram in your slides just showing from new service to the production-ready service. There's a bunch of essential parts we need to check, kind of a definition of done for the production-ready service. I noticed that you said you designed such a system to generate it or to do some check on these services if such service has those essential parts. And you also mentioned that every engineer has their own pipeline of deploying their own services, or I don't know if I heard it wrong, or they have their own tech stack. So how does it work? How is there so many, like every engineer defines their own pipeline, and how do you enforce such essential parts check?
So I'm going to answer the first part of that question, and the second part of your question is going to be basically our next section of this presentation.
Oh, cool.
But the first part is to give you the details on that. So the generated thing is only for the new stuff. It doesn't check existing services. But we are working on a tool that will also enforce these checks on the existing stuff. So basically, like you launch something and you kind of like can say, is this service really production ready? Like a system that automatically does like load tests and a bunch of other kind of like similar tests to define like, you know, is your service according to SLA? What's the latency? Is it acceptable? And so on, and stuff like that. So.
Okay, I see.
But for the deployment and stuff, this is the, all right?
So it's more like a testing other than static check.
Yes.
Okay, I see.
Thank you.
All right. So I'm gonna give the mic to. Yeah.
Sure. All right. Thanks. Thanks, Will.